Hi, my name is Tracy Finara, PhD, environmental engineer, and earth advocate. I will go to some of the world's most extraordinary places and some of the world's most gruesome in search for environmental problems and solving them through principles of science. My goal is to make this world a better place for all species, today and in the future. Today, we are here at the University of Florida campus at Lake Alice. This lake was historically a sinkhole which would treat wastewater and stormwater, and it took until the late 1950s for people to realize that it was a bad idea to put wastewater into a sinkhole that leads directly into the Floridan aquifer where we get our drinking water. Right here is one of our about 18 inputs to Lake Alice that is not regulated. For some reason, Lake Alice is exempt from any regulation on nutrient loading or pollutant loading to the lake. Oh my, what is that? Hold on a second. Oh my gosh. It's a dead fish. Actually, the fish population here at Lake Alice has decreased about 85% in the past 3 years. Let's find out why. First, I'm going to take this fish to the lab. Good thing it's Lent and it's Friday, because we got sushi tonight! Alright, so do you see all this algae over here? This is actually a response of the water body to nutrient loading, which is phosphorus and nitrogen. You'd think that nutrients would be a good thing, but everything in moderation. Sometimes too much of a good thing is a bad thing. Algae blooms form, creating a thick green paste, and kill everything underneath it because sunlight can't get down there, photosynthesis can't occur, and the fish have no food. Alright, so this is a pretty good sample that we have here. What I'm going to do real quick before we go into the lab is test the pH. The pH can tell us a lot about a water system. So the litmus paper didn't really change colors, so that doesn't really give us any information. So we're going to go to the lab and find out what's going on. First, we're going to take samples all around Lake Alice and find out where the problem is coming from. Alright, so let's take a sample over here to see how our contaminants compare to the different locations around Lake Alice. As you can see, all this trash here, there's cans, bottles, and I'm sure plenty more. And these articles were probably not dumped right here. They were probably dumped outside a car window or on the street or sidewalk. Stormwater picks that up, and your stormwater actually goes right here. Contrary to what a lot of people think. Either people don't think about it or they think that it goes to a wastewater treatment plant, which isn't the case. It goes right into your natural water body. Oops. Alright, sample number 2. The turbidity of the water is pretty high. It's not very clear, which doesn't actually mean that it's unhealthy. It is very well connected with algae blooms and excess nutrients and tannins. So, ground zero, where it all begins, we followed the pipes all the way up to here, well, the pipe with the highest phosphorus concentration, and it is linked to the brand new lacrosse facility that was just built a few years ago. It is also right next to this softball field, but you can see right in here all the algae that is already built up just in the incoming stormwater, which, I mean, usually the water isn't standing as much as this is, but that just goes to show that there's probably a very high nutrient content in the stormwater runoff from this field. We're going to take another sample and take it to the lab. now we're in the lab. We took our samples, put them through a filter, and then acid digested those samples to try to find out what compounds are in our samples. And we have some surprising results. Not only do we have very high concentrations of phosphorus and nitrogen, we also have high concentrations of copper sulfate. Now, copper sulfate is used to control algae blooms. A lot of times we end up treating the symptoms and not actually fixing the problems, as in this case. So the high nitrogen and phosphorus could be contributing to algae blooms, which could cause fish kills, but I think our culprit here is copper sulfate. High amounts of copper sulfate can directly kill fish and aquatic life. So what we can do to alleviate this problem is stop adding copper sulfate into the lake. And then the nitrogen and phosphorus concentrations are still very high. So in order to limit those, what we should do is implement low-impact development design practices where we encourage infiltration so the rainwater can be naturally filtrated through the ground and treated before going to a lake or river. A lot of times we have designed areas to get rid of the water as fast as possible to prevent from flooding, but this does not allow for any treatment prior to outfall into our natural water body. Everything in this world is connected and everyone makes an impact. It's your choice whether that impact is positive or negative. So let's make it positive and be superheroes for the planet together.